Hello, myself Praveen Vyas, student of Mechanical Engineer from Engineering College Ajmer, presenting a presentation on Scuderi split cycle engine to respected Assistant Professor Mr. Tarun Kumar Aseri sir from Engineering College Ajmer. As we all know that the first four-stroke piston was developed in 1876. The first the four-stroke piston arrangement is still the primary design of engines built today. Today engine operates at only 33% efficiency. This means that only one third of the energy in each gallon of fuel is used. The rest is lost through friction and heat. If we do little bit changes in design of four-stroke piston engine, then it will very efficiently give result. With over a billion engines currently in worldwide, even small gain in efficiency will have impact on the economic dependency on foreign oil and the environment. This is the basic difference between the IC engine and split cycle engine. As we all know that the four-stroke performance of IC engine, there is an intake stroke, compression stroke, expansion stroke, and the exhaust stroke. In simple in simple IC engine, there is a one cylinder, one piston, and one crankshaft, two inlet and exhaust valve. A spark plug is designed. In split cycle engine, there is two cylinder. This is the cross section view of split cycle engine. There is a two cylinder. One name is a compressor cylinder and another version one is power cylinder. There is two piston and both the piston are connected through a crankshaft to a single crankshaft, and the both piston are connected through a crossover passage. This engine is proposed by late Carmelo Scuderi, who spent over 40 years inventing, developing, and commercializing new technology. The Scuderi split cycle engine technology changes the heart of the IC engine. Split cycle engine divides the four stroke of intake, compression, power, and exhaust into two separated but paired cylinders. The first cylinder is used for the intake and compression. The compressed air transferred through a connecting passage or from the compression cylinder into the second cylinder where combustion and exhaust occur. As you have noticed that this is the first intake and compression process take place in this cylinder, and the exhaust and expansion take place in this cylinder. This is the basic component of screw-drive split cycle engine. There is a two cylinder, compression cylinder, expansion cylinder, compression piston, expansion piston, crossover passage and crossover valve, intake valve, exhaust valve, crank and crankshaft. Fuel injector is in the compression cylinder and the spark plug is in expansion cylinder or power cylinder. Now, as you all see that this is the working of Scuderi split cycle engine, in which the green color represent the intake of air plus fuel mixture and the blue one is representing the compression of air and fuel, which is goes from the crossover passage valve and converted into the power stroke, in which the air and pressurized air and fuel mixture comes into the power stroke, and when it is come in the power cylinder, the spark plug ignites the power and expand it through the bottom dead center, and then the yellow one is the exhaust through which the exhaust gases goes from out from the cylinder. As you have noticed all that the valve opening timing is very important in this. I will discuss this about in next slides. The split cycle engine divides the four stroke of the Otto cycle between two cylinder, one suction compression cylinder and another is expansion and exhaust cylinder. The process of suction and compression take place in the compression cylinder, and the process of expansion and exhaust take place in the power cylinder. The compression cylinder consists of a piston, inlet valve, and the crossover compression valve. whereas a power cylinder consists of a piston, exhaust valve, and crossover expansion valve and the spark plug. Now we discuss about the pressure volume in compression cylinder. In compression cylinder, on the intake stroke, the inlet valve open on the compression cylinder when the piston at the top dead center, the inlet valve is open and the air and fuel mixture comes into the cylinder. The then volume increases as piston moves from top dead center to bottom dead center. Then inlet valve closed. The volume in cylinder decreases as the piston beings compressing the trapped air to high pressure air. When the pressure reaches 50 bar, then crossover inlet valves open and the pressurized air transferred through crossover passage valves to the power cylinder. When the crossover outlet will open, when the power piston is almost at the top dead center, the crossover passage will open and the pressurized air gas is transferred into the power cylinder. Now the fuel is injected into the power cylinder at 50 bar. Spark plug ignites the fuel and closes the crossover outer valve so the exhaust gases does not move back from the crossover passage to the compression cylinder. The piston reaches bottom dead center, volume increases, pressure decreases. Now the exhaust will open and exhaust gases are pushed out of the cylinder. The crossover passageway is the shortest way to connecting the cylinder, and the design of crossover passageway is very important because the conventional cam actuated valve admits air to the combustion chamber, but a pressure actuated disc type valve admits air into the passageway from the compression chamber and prevent it from leaking back onto the intake cylinder. When the high pressurized air fuel mixture moves from the crossover passage from compressor cylinder to the power cylinder, there is there is a chances that the high pressurized the high pressurized the high pressurized air fuel mixtures goes back through the crossover passageway to the intake cylinder or compression cylinder. To avoiding this situation, there is a use of a pressurized activated disc type valve due to which this situation does not occur. There is a drawback. There is many split cycle engines are invented and discovered, but there is a drawback of split cycle engine, which is overcoming by a Scuderi split cycle engine. The Scuderi split cycle engine solving both the breathing and thermal efficiency problem. The breathing problem is overcoming by the lagging of power cylinder piston by 15 to 20 degree. Due to this, no more high pressure gas trapped in the compression cylinder. The piston used cylinder, solving the thermal efficiency problem by firing after the top dead center in power cylinder. Scuderi air hybrid engine. Scuderi air hybrid engine is the first hybrid system that makes sense because split engine is really a compressor on one side and engine on the other side. It simply required the additional an air storage tank and some control to convert it into hybrid system that can recapture and store the energy. This can be possibly by using compressed air as an energy storage mechanism. In the next slide, we see that the normal operation of split cycle engine to make it hybrid split cycle engine only we use a extra air storage tank. Now I will explain how a system can be used as air hybrid engine. The regenerative braking, how it regenerative braking, the power cylinder is turned off while the vehicles remain engaged with the engine. The force of stopping the vehicle continues, the engine pumping compression air into the storage tank. High efficiency mode. The compressed cylinder is turned off and the power cylinder is fed pressurized air from the storage tank, eliminating the loss of compression. Crushing mode. The compressed cylinder takes in charge of air that is only partially used by the power cylinder. The rest of the air is used to charge the storage tank. There is an advantages of screwdriver split cycle engine. Engines only take one crankshaft revolution to complete an entire engine cycle, whereas in IC engine there is two revolution to complete one engine cycle. A power stroke occurs on every cycle. This results in the split cycle having performance characteristics similar to a two-stroke engine without the problem associated with the two-stroke, such as short circuiting and burning of engine oil. Fuel is injected into the crossover passage, allowing for good mixing of air and fuel, creating well-prefixed mixture. No risk of knocking on the compression stroke as only air is compressed. Thank you.